Alright, we're looking at GSRT 7. This video is for worksheet number 1. And I guess this particular concept comes from some of the patterns found in relationships between sine and cosine. So what I want to do here for just a minute is just take a look at some interesting things that happen here. Let's pick a number in the trig table. I don't know, let's say sine of 10. The sine of 10 degrees comes out to 0.1736 or something close to that. Now let's go looking through the table to see if we can find that number somewhere else. Over in tangent, not quite close. Let's see here. The numbers are getting smaller for cosine. So here I go. Hey, look at that right there. Take a look at that. That's an interesting thing, is that cosine of 80 has that exact same value. So this value right here in my table matched, where was it? Right, cosine or sine of 10 right here. Very interesting. Let's see if that happens again. I don't know, you pick, let's see, 28. Let's pick sine of 28. Sine of 28 degrees comes out to 0.4695. Let's go find that number in the cosine column, if it exists. See, that's counting down, so let's go over. We're looking for 0.46. Whoop, there it is. Let's circle that. Where is it? Right here. And that would be cosine of 62. Alright. I don't know, maybe somebody's seen something interesting in the pattern so far, but maybe not. Let's get a couple of results so we can talk about them. Let's pick, let's do cosine first here. Cosine of 50, let's say. Cosine of 50 is 0.6428. And where do you think we will find it in the sine column? Let's see if you're seeing a pattern yet. If you don't see it, let's go track it down. Let's see, sine, and we're looking for 0.6428. There it is, right there. At 40. Wow, that's interesting. So let's take a look at what we're finding here. We're finding that the sine ratio and cosine ratios are equal sometimes. In other words, the sine of 10 degrees is always going to be the same as cosine of 80. Or the sine of 28 will be equal to the cosine of 62. Or the cosine of 50 will be equal to the sine of 40. Now what is it about these angles? Can you see a pattern in them? Let's take a look. Maybe this way is easier. Let me circle them. 10 and 80, 28 and 62, 50 and 40. Do you notice that they equal 90 degrees together? In other words, they are complements. So we've discovered kind of a cool little relationship, that the sine of some angle, let's call it x, will always equal the cosine of whatever's left over of the 90 minus that x. These are called cofunctions of each other. They will always be equal. They function off of each other as long as their sum comes to 90. So let's just test one out. Let's pick a number like what? I don't know. 32. Let's pick 32. So that should equal the cosine of 90 minus 32, which is, of course, 58. let's go check it out. Is the sine of 32 the same? Let's see, the sine of 32 came out to 0.5299. And let's go over to the cosine of 58. Cosine of 58, there it is, 0.5299 as well. So we've got a nice little relationship. Now the question is, why does that happen? Now there's the real question. Let's tell you why. Well, because those two angles always equal 90 together, let me put in my values here. Take a look here. The sine of 23 degrees in this triangle would be y over z. The cosine of 67 is its adjacent y over z. Ah, that's why they're equal. Because when they equal 90 together, they're in the same triangle looking at physically the same two sides. So when they sum to 90, we know that they're in the same triangle, and one's looking across the triangle at y over z, and one is looking to the adjacent y over z. Again, let's just show you what I mean by that. Okay, so that's what this is showing, is that, again, doesn't matter what corner we're in. Let's say we wanted to do the cosine of 23. That would be x over z. And we would do, let's say, the sine of 67, which would be opposite over hypotenuse. And we get that same relationship. Kind of a fun little idea. It was interesting that it appeared, but ultimately a pretty easy idea that we're in the same triangle. So we'll see different questions to solve. Just very easy ideas that if this is 63, we are at 27 degrees for this value. Here, guess what? If the sine of 45, then this has to also be 45. So at that moment in time, they would be the same. Let's go back to the chart and see if that was true. Here we are, sine of 45, cosine of 45. Yeah, look, they are equal and in the same triangle. They try and make these a little trickier by basically putting in some algebra, but what you know is that this angle, whatever it is, plus this angle over here has to equal 90. So you just set it up and solve like any other problem. 2x equals 80, x equals 40. One more and then we'll call her quits. X plus 5 plus 4x plus 10 equals 90. 5x plus 15 equals 90. 5x equals, 75. And so we get 5 times our value of 15, and we get our value. All right.